I have to actually turn my microphone on. It's a good start. Would be a good start. Is this reasonable? I think it is. Like that. I think this is okay. All right. Let's go with this and see how we go. Take my headphones off because I just think that looks so weird. People doing this stuff with their headphones on. Maybe it's completely normal, but all right. So I only have about an hour today until I am expected to go home for dinner because it's Friday and we need to do dinner and we need to do drinks. But before then, I'm actually going to try and get something done today. Whereas yesterday, not a whole lot happened, although it was fun. So we're going to get back into doing some actual programming. All right, so like yesterday, we ended up with basically just setting up a task list of the thing that we wanted to do and implementing only a single method of that so far. So let's see if that's actually still working. npm test. Did I have the camera in a different way than I had yesterday? Maybe. It's actually just my laptop sitting on a little stand that moves every single day. So it's definitely changed a bit. All right. Let's give this a go. Okay, so all the tests are passing and we've got 100% test coverage. So yay. Software works. Nothing broken. Let's go home. But it also doesn't do them much yet. So yesterday we implemented the task source. And just to remind everyone what we're doing is I wrote a little example, which looking back at the stream of yesterday, I probably should have done as a first thing, not as a last thing, but here we go. We've got it. We basically want to take in a stream of events, which we define here by its topic name in Kafka, take that source and process it. So, and then, but at the moment that we call task process, we don't actually we actually don't want any processing to happen yet. We basically want, we only want processing to start and connection to Kafka to start once we run task start, which makes sense if you're trying to start something. So that also means that instead of calling task start, we want to be able to call task inject and as an interface to test the processing logic that we've defined as part of task process. So what task process really does is just record the process topology. It doesn't actually do any processing. It doesn't actually call any functions that will do the processing. It basically just remembers the topology that you've created. Because you could, for example, instead of over here, the idea is that we write back to a topic. But what if instead of doing that, we take all these location events that are coming in and we look up the count, and what if we return that new count? Then you could basically say this, event counts is, and then just like we've processed the location events, we should then be able to process the event counts as well. Assignment. So this is basically, we haven't actually done this yet, But eventually this is something we want to support in order to really be able to create pipelines of processing. So with that in mind, basically we need to be able to register multiple of these functions per source, and we need to be able to put them in the right order, and then we should be able to build multiple topologies on top of that. We do have the restriction that basically, I think for now we're just going to go with the fact that each source can only be processed once. And that's basically because otherwise the consuming of Kafka is going to get really complicated, because you're going to have to basically subscribe to topics more than once with multiple groups, and stuff just gets really complicated. So far we haven't really found the need to have more than one processing pipeline per source. Because what you could always do if you, let me not explain that, because it's just going to make stuff more complicated. I'm just going to revert this for now, back to what it was. Can I just hit Command Z like a peasant? Yep. All right. You could have just, I'm actually going to leave the task inject here and put this back here. Okay, so that's the thing we want to do. That's what process needs to be able to do. So let's go and implement that. Task, that's what we're looking for. Okay. So what we want to take is we want to take a source, and we want to take up a function that sets a setup processor. And now this is where I'm just going to leave that type for now, because I don't really know how to do that. I think you can have function interfaces within TypeScript. For people that haven't watched yesterday, this is my first ever go at TypeScript. I've read through maybe a page of documentation, and I'm just sort of making stuff work in general, rather than trying to learn everything, because that's sort of the way I learn anyway. I mean, at some point, generally what I do is I introduce myself to a topic, then I start hacking on it, and as I run into issues, that's when I started reading documentation, and before you know it, I have read all documentation. But sometimes with some projects, I actually end up not reaching certain parts of documentation. Sometimes I then read them later anyway, just to get a complete idea of what something is. But I often take that as a sort of as an indicator that that feature might not be so necessary, or it might not be so useful, or it might not be super pragmatic, or especially with things that grow a little bit bigger, there's always plenty of that. So I really like to just explore my way around and see what works and what doesn't work. And anyway, so process. When I take that function, can I just say function here? Probably not. All right. So we're going to take this source, and in this source, we're already keeping a list of processors, or I should say over here, we're keeping a list of processors. So basically what this is going to be is we're going to, in a very ugly mutating way, we're going to push the processor. Is that what I'm going to do? Because if we push that to the array, you know what? This is so like I'm going to actually just clone this thing. Does that make sense? No, because we're gonna mutate processors anyway. Like, I really like to make stuff immutable whenever I can, and when there's not much reason to not make it immutable, like if we're doing something multiple times a second or something like that. But No, we're actually going to go do this way because nowadays in year 6 we can do this quite neatly. We can say take this array and take that array and put setup processing on top. And yes, I understand that this creates an entire new array. Yes, I understand this creates an entire new object. That we're basically concatenating an array rather than like concatenating 2 arrays. Then we're really pushing to an array, and that is not anywhere near as performant. But this in the live of it is not going to be a performance bottleneck. And I like the safety of immutability if I can get it. So just gonna do it. Let's see if I'm really missing something massive here, just from we've done this before. Yeah, I don't think we are necessarily. We might. The one thing we might want to check if this source is actually a source that we're tracking. Because you could have multiple tasks open at once. You could have multiple instances of tasks and mix and match these sources, and then this would break. So let's actually just try and find the source. Let's say existing source. And the key that we have these sources by is the topic name. So if the existing source, let's look at the existing sources and find the topic name T. Oh, wait, we can actually just say topic name now, can't we? And then if we can't find this, throw a new error. I'm just gonna go with a generic error for now before I really start attributing. Should just make, no, I'm just gonna go with it. Wait, there is actually an argument, like a legal argument error, isn't there? Or is this not really what this would be? Illegal argument error, is that a thing in JavaScript, or am I just making stuff up? What do people do? Does not have one. Woohoo, okay. I don't know why I had that in my mind. I don't think I've ever done that either before, but anyway. Actually, that would require getting another dependency. Because the thing I really like is I like to use the invariant. There's this package called invariant, and it basically allows you to do this. It says invariant. It's like a, as far as I understand, it's a functional programming thing. Existing source must be created. Must be created through task. Because I guess I'm gonna say it must be known to the task, but the only way that a task will know about a source is if it came straight from there. A source must be created through task to create, to process it. Yeah, I think that's fair enough. Okay, I'm just gonna pull in that invariant thing, or let's just, maybe we can just even, maybe it's a little enough that we can copy and paste it into our own utility thing. Hello, new window, please. Invariant. Because that's basically when I write JavaScript, it's what I use in order to do type checking. So I write through all my invariants, and then When processed, Node is not in production, the message is required if omitted. The value of okay, so let's look at the actual source of this thing. What BSD MIT. License MIT, permissions, commercial use, modification, distribute, liability, warranty, conditions, license, and copyright notice. You know what? I'm just going to pull this in and deal with getting rid of it later because I don't want to spend my time on it right now. So yarn, no, we're using npm with this one. Invariant. Okay, now let's write a test. T-test task process async T. Task process source, and then we're gonna have to do that with some sort of a function. Asynchronous. I'm just not really gonna care about what this kind of what the function is really. I'm just gonna doesn't really matter yet because we're not calling anything yet. All right, let's give that a test. Oh wait, what I've totally forgot to. Sorry, people. Guess that's pretty bad. Totally forgot to up my text size. Apparently nobody is actually that should make things a lot better. Task process this source. No, we're not going to do anything with that, we said. Cool. Using invariant has one side effect here, is that because the code runs, code coverage isn't showing it as something that we haven't tested. Because the difference is that if you say this, if existing source, if we don't have that existing source, and we throw an error, let's just use the same error. Through same instant that processes it. Sorry, much created through same test that processes it. That's probably actually better. Because now, if we now run this test, we're going to get a code coverage issue, which indicates to me that I haven't tested the fact that this thing might fail and that I might be trying to call it with a different source. And that's the kind of thing we want. So I think we've answered our question about using invariant ourselves and getting rid of that. We're just going to get rid of it. Uninstall. Wait, did I actually even save it? I didn't even save it. So it's not even in my package.json, is it? Nope. Well, For everybody yelling at the screen earlier, I'm sorry about that. It's Friday afternoon at 4:30. I'm gonna forget to add save. Actually, what it really is I'm used to using Yarn with in the day-to-day work that I'm doing, and Yarn doesn't require the save flag because it saves it by default. So I'm blaming Yarn, or I'm blaming NPM. I don't know. I'm blaming everything but myself. That's what this is turning out to be. Okay, so task process. Now we need to test the fact that you know what, let's just, the task is create task. Throws. We want task process to throw. We want task process to throw. It's definitely Friday. I guess I'm starting to just completely lose my train of thought. Oh yeah, we want to take that same source and try to, with this other task, try to process it. And that should throw, because that source came from that task, not from the other task. Right? Why is there a line under this? Let's say expected arguments 2, but got 1. It's very true. Thank you, TypeScript. And we're back to 100% code coverage. So far, this is not a whole bunch of code, but that's actually because all of this pre-stuff is quite simple. It is where we get to the actual starting of the task or implementing of the task where things get a lot more complicated. Anyway, let's commit that. Let's put this back onto font size 18 so people can have some idea what I'm writing. Suggest we might use task inject in the example. Cool. Next up, okay, so we have this. The next thing is to call task start. Now, I don't want to do that yet because that means I will actually have to start connecting to Kafka, and I need to set up a Kafka environment and a cluster and Docker and stuff. And the last thing I want to do on a Friday is set up a Kafka cluster. So, to see people who've done that before and have done Docker work before, maybe that's your cup of tea, but it's definitely a chore for me rather than something I like to do. So I'm gonna say if I'm gonna go do that, I'm gonna stop working at all, but I want to get something done, so I'm gonna do something else so that the time I am using is used properly. So instead, I'm gonna try and make inject work. Let me have a quick idea of what our idea was for inject. So inject will have to take an assignment, I believe, and an assignment has a topic, a partition, or assignments. I want an array of this. A topic, a partition. What else do we get? Do we get an offset? A starting offset, maybe? let's see, context, local. I'm just gonna go with this, because basically whenever you connect through to a consumer, you're going to get a like a rebalance, or like when you join a consumer group, I should say, a rebalance event will happen. And when the rebalance event happens, a leader is chosen, and the leader then assigns you one of the topic partitions that you've subscribed to. So most of the time that's one topic, sometimes it's multiple topics, but it's basically in a way for a consumer group to balance the load between multiple nodes at the same time. And if there's too many nodes, there are nodes that might not have any partitions. But it's extremely, it's basically this entire thing that allows you to run multiple workers and scale horizontally, basically. Because the partition is the unit of concurrency in Kafka. So we're gonna get multiple of those. And basically what we want to start doing for that is we want to start returning, we want to pass that to that setup processing function that we got, and we want to simulate the setting up of an assignment and then return an interface to the user that they can use to inject messages. And let me just set up an example for inject. Maybe that's just a useful thing to do as well. We'll take some of this because that's not really the thing that matters. I can remove this. All right. Test interface, and then I don't really know what to call it yet. So, but we're gonna get the task, and we're gonna say inject, and then we'll inject one or more assignments. Let's just say one assignment for now, and we're gonna say topic, location events, because that's the topic name we're using in this example, and then partition 0. It's all 0 indexed in Kafka, so we might as well stay with that. Yeah, let's just go with that for now. And then that should return us a test interface. Do I want this to be asynchronous? Who knows? We'll figure it out. Yes, I want this to be asynchronous. Yes, I want this to be asynchronous because the setup of an assignment can be asynchronous. It will make more sense later. Test interface now, and then with this test interface, we could inject itself. Send, maybe send is a good name. Send a location, a message. Location events. We want to write to partition 0 as well. Wait, do we want to say send? Anyway, the point is that key null value, what were your location event? Location event, I don't know. That's probably not what makes sense here. Oh yeah, something with a timestamp. Let's say test message. Test location, that makes more sense. Is a something with a latitude. Okay. That's not a latitude. 4 is probably latitude. Longitude. 4 is also a longitude. But let's not do that because that makes that more confusing. And a timestamp is I don't know, date now. It's just an example to show that you can now produce that message. Test location. So you can inject this message, and basically at this point, you should this message should be injected. This assignment should be set up already here through the test interface. The assignment should be getting set up, and now the message should be run through the processing logic. There's one thing though that's not gonna. We can probably say result, but in this case it's not gonna really matter because we're not really returning anything. So let's, for the fun of it, let's just not do that. Let's say test interface committed messages, and then and now this should contain offset of message because we called context commit. So that's basically the interface. We want to return an interface, so we want to prime the processing context, and we want to return an interface that allows us not only to inject messages into that context, we want to be able to see the results of that. So basically, we want to be mocking an entire processing context in this way. So it's pretty complicated, but it is really well worth it. We used to not have this in our own version of this system, and testing stuff was difficult, and knowing whether something was a bug in our processing logic or somewhere down the line was really difficult. It was really hard to distinguish from other bugs in the framework. And as soon as we could actually do this, as soon as we could actually take the processing logic and just assert on the outputs of that, assert on the results of that, it's been so great. Like we've been able to create way more intricate processors, way more subtle ones, because we can actually just test the whole thing without having to spin up an entire Kafka cluster, actually write messages, create a new topic, all this sort of stuff, deal with rebalance events. Because so anyway, so I'm going to leave that there. That's what we're going to try to do. So let's write a test first. Why not? Task inject async create task. We'll do that first. Basically, we can copy paste this because it's basically the same. And then task inject. Task inject, yes, task inject. And then we want to give it a topic of test topic and partition 0. Yeah, first I just want to test the actual test, just the function itself, and then we'll create a separate test suite, a separate test to actually start testing that interface. So let's see how we do that. Here we go. All right. So far we can just return. Let's start with the beginning. Send is a function. We want to include that. Committed messages, an empty array. Should be commits, committed offsets. Ooh, we're offsetting commits, people, not messages. See, I want to call this produced messages or sent messages actually, but then It's almost like this is going to be in that. Inject. Then we have two injects. Trying to figure out what to name stuff. It's difficult. It actually doesn't really matter until we... Isn't that what TypeScript or type languages are supposed to be good at? Refactoring? Renaming stuff? Yeah, okay. See, so I would actually give this thing a type, but I don't actually really know what it's supposed to be yet, so I'm just not going to, because I'm just gonna... Like, I could give this thing a type, but what the hell would I call that? So I'm just not going to. Like, let it... Can I do type inference from this? Maybe. Okay, so we're gonna take the assignment and we're going to take all of them. Do we map over this thing? We should probably do this at the beginning of the week rather than at the end of the week, which might be more productive. We need to introduce a new thing here, and that is I'm gonna go do something TypeScripty. Yes. Okay, export default is the interface of a assignment context. Now this holds a topic, which is a string. It holds a partition that so this is basically giving the context for this assignment that we're processing, and so it holds all these different types of information. It should hold the group, the consumer group that is, that we're consuming from. And then a whole bunch of methods. And that I'm actually going to just look at how we've done that before, because that was a real big trial and error kind of thing. Although we should probably start fairly simple, because we want to. I want to keep using that code coverage thing as a way to figure out whether we have bugs, so I don't want to start adding all these different methods straight away. We definitely want an event. No, it's probably an information detail. Pause, resume. Let's just start with this, because we're not actually calling anything yet. Assignment context processors. And the processors will pass to it. Let's just go with this and see how far we get. So this is a interface, and it won't actually implement anything, but oh no, wait, that's not the thing where... That is the type. Export. We do want to export that. Oh, what was that? But do you think we actually want to export is the interface of a function? How does that work? Do we like just do a function-y thing? Is that alright? Because what we want to say here is actually want to say a source here. Oh crap, I'm gonna need that source. So I guess source needs to be its own module. Because task is gonna have to require this assignment context. I hope that works that way. Let's see if it doesn't. Let's comment this out for a sec, because otherwise code coverage is gonna not like me. Source imports source from source. Okay, let's see if that works as a. I don't think it's gonna work because Sublime is drawing squiggly lines just about everywhere. Inject does not exist on type task. Oh, because I'm actually writing the test for it. So. Let's not save that for now. Task. Okay, so that does work. You can apparently export interfaces and types like that, which is pretty handy. Still don't know if it's a particularly great idea to do it like that, but why is this? This is just... It's just Sublime having a fit. No, it's not Sublime having a fit. Cannot find name source. Oh, it's doing an anything. Anyone watching, as in the 1 or 2 people that are, if you know what's going on here, please let me know. Crab script, lang. Documentation. Surely this is just a getting started thing, right? This is declaration files. High quality declaration file. I don't want a declaration file because that's like a header file. Modules. It's the concept of modules. Export interface string validator from string validator. Is there somebody using default in here? Default exports. Each mode can optionally export a default export or marked with the key default and can only be using it from are really handy. So handy. So I'm not really understanding why this wouldn't work the way I'm saying it does. Especially just because it does actually compile in TypeScript. So, but it says that it's an anything. So is that just why it compiles? Cannot find name source. But then what is this, dude? Don't know what I've just triggered here, but it looks useful. Don't know what that is. Cool. So source, export default interface source. So what if I do this? Surely now it doesn't compile at all. Or is it the same? Does it still compile? Because it doesn't matter. Cannot find name source. Okay, so here it does actually say cannot find name source. And so it must be finding something here. Right. One would think so, that this is a thing you can do. And so this should fail because I've made it the default export. Or maybe that's how ES6 modules work. Okay, it should now be able to find source. So now exported member source, exactly. Source from source. Okay, I'm just gonna ignore Sublime here for a second. Is it like, is there an update for the package? Package, update. Remove package, TypeScript. Yeah. Package, install, TypeScript. Installed successfully, and then this is TypeScript, people. TypeScript. Cannot find name source. Well, it's defined right over there. So who knows why that is? Wait, actually I can try something. Source, TypeScript, process sources is, if I just change the type, will it then start failing? Because that would mean that it's actually reading the type properly. Let's see. So I think just it's just Sublime. This is a rare thing to see in Sublime for things not to work like that, but I guess it does sometimes. It's too bad, but you know, I'm just gonna continue because it seems to be valid. TypeScript, cool. So now we can actually also import it from here. Import source from source. And it's gonna take us, okay, so this context thing, it's going to take a source and it's gonna take the assignment that we're trying to, no, wait. It's processing context. I'm a bit lost. Circular dependencies. How do you deal with that in TypeScript? I want to, yeah, I need a task in here, don't I? Okay, I'm gonna take the assignments, I'm gonna take the task. That's what I'll take for now. How do you interfaces? Functions, is that a thing? Yes, it is. No, I want a function interface. I just want a interface function thing. You can write same read only properties, just property checks, function types. Here we go. That's how we do that. Interface search function. So that, right? That's not too bad. It's going to return a assignment context. That's what this thing's going to return, because we basically have to create one of those, and we'll be able to create multiple of them. And then, but obviously, so this is just an abstract interface. I'm going to have to implement that thing. Can we do that as well? And then obviously implement. Oh, I'm almost running out of time. So I still want to write this though, so that I have some idea of where to continue. Import source. Import. Local. It's really Friday, I can tell. Assignment context, we need that. Create context, and I think this is how you do this in ES6 modules. Let's see if it compiles. It does compile, so it must be doing something not completely wrong, I hope, unless we're not. No, wait, we don't know that yet, do we? Whoops. Import. That is not a pretty name. Assignment, contexts, local. Local has no default export. Alright. Should probably write some code. Oh man. Export default function. And it's, what do we say it should do? No. That one, please. Oh, we already had it open, that's why. Hello. It takes that. It takes assignments and it takes a task. I guess this without types doesn't really do too much, but we're gonna add some more stuff to that, and then it will make more sense. It should probably return an assignment context for every single one of them. So. Wait, no, that's not what we wanted. Array. Okay, I guess that's not something you can do. Return assignments, map. Return. So we're basically returning what was put in at this point, but we're going to be adding the contextual methods that we can use on top of this eventually. But for now, I'm just trying to get all these types to not completely bite me. Times maps. Did we say what an assignment was here? For all the assignments, contexts is assignments. Doesn't do anything yet, but it will be interesting to see whether one compiles. It compiles. But now we're going to get a code coverage issues. So we're going to start testing what we've just written. Test. What are we going to test? The task. Okay. Cool. Functions does not meet global threshold. We'll try to do something about that later. Yeah, and we can't really do too much about this yet. Okay, well that's fine. So which functions does it not hit here? Ah, this function, because we're not doing anything with it yet. Well, I guess we can say interface. Test interface. And then test interface inject. %100% coverage. All right, well, it's still a little bit of setup. And one of the things that I'm a little bit confused about is because I think this is the way that we have done this. So instead of creating an assignment context for every single assignment separately, we're creating them all at once. And I think the idea is about that was that when we run in production, we can choose to keep certain contexts alive rather than recreate them. Only end the ones that need to be ended after a rebalance, because you can have a rebalance and get topic A with partition 0 and 1. Then there's going to be another rebalance where you get topic A and only partition 0. But instead of having to completely set up that new assignment context and completely restart all of your processing, because all the processing happens within that assignment context. Instead of doing that, you can just keep 0 running. You can just stop the assignment context for partition number 1 and stop with partition number 0. And I think that's why we've done it like that. But at the same time, we've ran into reasons why that might not be exactly the right thing, and where we might want to where we might actually want to pass the processors to the assignment context so it can do the setup. It's something that I'm gonna think about a little bit. Not so much over the weekend, because that's when I should be doing other stuff, and I should be unwinding. But I think it's something that it's something that I'm gonna have to think about a little bit, go back through all of our documentation to see where we sort of landed on that. Anyway, we haven't done a whole bunch more than last time, but because we're still getting to know TypeScript mostly here. But at least we implemented a couple of things, and we've entered here with 100% text coverage. We've added stuff, and we're still at 100% text coverage, which is great. So I'm just gonna actually commit some of this stuff. An example of how task inject. Draft assignments. Draft task and inject, that's fine. That'll do. All right, I'm gonna push this in case anyone wants to see what we've been doing. I'll go to the GitHub page for it. It's at Jaap wrote. And then the thing is called Frolic. And as you can see now, there isn't that much that works yet. But if you do want to dig around, if you want to have a look and see what we're doing so far, that's the place to do it. All right. Well, I can definitely tell that I maybe shouldn't be doing these things right at the end of a Friday. Makes stuff a little bit more complicated. Definitely makes it a little bit harder to think clearly. But at the same time, I have to balance it with client work, right? Because, I need to be able to work in a focused way on my client work as well. And give them everything, work to my abilities there as well. So I think I'll do another one next week, probably again on a Thursday. That's probably the best combination for me of not being completely at the end of the week where I'm mentally getting exhausted, but also at the point where I should have done most of my client work for that week. So I know I can do some streaming and work towards this. While not having to be too afraid of not getting my client work done, because most of it should be done. And if I didn't get anything done, then I guess I just won't be streaming. So anyway, tune in next time, or not. 3 people that watched today. Yeah, I hope you enjoyed yourself. And I'll see you next time. Bye.